Section 1.7 Inverse Functions. Inverse functions, definition. For any one-to-one function f of x equals y, a function f inverse of x is an inverse function of f if f inverse of y equals x. This can also be written as f inverse of f of x equals x for all x in the domain of f. It also follows that f of f inverse of x equals x for all x in the domain of f inverse if f inverse is the inverse of f. The notation f inverse is read as f inverse. Like any other function, you use the variable name of the input for f inverse, so we will often write f inverse of x, which is read as f inverse of x. Keep in mind that f inverse does not equal 1 over f of x. And the reason it warns you about this is because if we see, for example, an exponent of -1, we usually tend to think to rewrite it into a fraction. However, that little -1 does not have a property of an exponent. It's mainly used for notational purposes to let us know we're working with an inverse. Now, I also want to highlight that it tells us a property of inverses. That means composition of f and f of x and composition of f and f inverse should result in x. And also, not all functions have inverses. It's only very special functions that have an inverse. Let's continue with example 1. If for a particular one-to-one function, f of 2 equals 4 and f of 5 equals 12, what are corresponding input and output values for inverse functions? Okay, so with an inverse, it's essentially the mathematical opposite. So it's your function opposite. So we're talking about your domain and range. If I'm given a point x, comma y for a function f, then its inverse will have those values swapped. And this is because your domain of your function, you have a domain which results in a range, while your inverse function has those same values but in different positions, so that your domain is made up of the range of your function f, and likewise your range is made up of your domain of your function f. So if we're given the values of f as 2 and 4 and 5 and 12, then that tells us that our inverse function will have those values but swapped, so that we have 4, 2 and 12, 5. So if we were to have a function drawn out with the coordinate points, we simply swap your x's and y's to get your sketch or your points for your inverse function. Next example. If f of x equals 1 over x plus 2 and g of x equals 1 over x minus 2, is g equal to f inverse? So we want to say, is this f inverse of x? Well, to do so, we have to prove it. And the way we go about it, according to our definition, is using composition. So we have to show that f composed of g equals x, and g composed of f equals x. I should write that so for the first one. F composed of g is equal to x. Okay, let's figure this out. So for the first one, it's saying that we're taking our function g and we're plugging it in for your x. so that we have 1 over, instead of x, I'm writing my entire function g. So I have 1 over x minus 2. And then my function is 1 over x plus 2. Okay, there we go. Let's go ahead and clean this out. So I have I have the minus 2 and the plus 2. So I'm left with 1 divided by 1 over x. Okay, don't let the division throw you off. Let's rewrite it. So I have 1 divided by 1 over x. And if you recall how you divide fractions, it's 1 times your fraction swapped. So I have x over 1. So 1 times x gives us x. Now let's do it the other way. Let's prove composition for g of f equals x. So what this is saying is I'm going to take my entire function f and plug it into my x in your g. So that we have 1 divided by 1 over x plus 2 minus 2. Okay, so I have to clean up this first part. Let's rewrite it so that I have 1 divided by 1 over x plus 2. So remember how you multiply fractions? I'm sorry, divide fractions. You change to multiplication, and you flip your second fraction. So that you have 1 times x plus 2 over 1. So it's really 1 times x plus 2, which just gives us x plus 2. So now we're left with, let's bring down the 2, x plus 2 minus 2, which is just x. So yeah, we have proof that f and g are inverses. So we can say something like, yes, f is equal to, or what did it say? F inverse is equal to g. Finding domain and range of inverse functions. The outputs of a function f are the inputs to f inverse. So the range of f is also a domain of f inverse. Likewise, because the inputs of f are the outputs of f inverse, the domain of f is the range of f inverse. So like we said, your domain and your range are swapped. So for your function f, if you had an a from the domain that brings you b from your range, it'll now be the domain of f inverse, resulting in the range of f inverse. So you're swapping these values out, given if you have a function and its inverse. Definition of domain and range of inverse functions. The range of a function f of x is the domain of the inverse function f inverse, and the domain of f of x is the range of f inverse. So remember, your domain and range swap. I always think the wording is so tricky, but it just means they swap. Example, a function g of x is given in the figure. Find f of 3 and g inverse of 3. Okay, so f of 3 means my x is 3 and my y is, well, I don't know. Let's find the point. Here I have the point. This point for 3 is 3 comma 1. Now, I think I meant to write g because this is the function g, not f. So I have my graph g, and I found that g of 3 is equal to 1. And again, if you need a reasoning, it's because we have the point 3 comma 1. where that's your x and that's your output, f of x, or in this case, g of x. All right, well, if I want to find the inverse for an inverse function, they just swap. So g of 1 is equal to 3, but it's not asking that. It's asking for the inverse of 3. So this would be it. I have the point 5, comma 3. So if I want to find g inverse of 3, it would come from the point 5, comma 3 because my output is 3. And again, your values are being swapped. Next example. Find the inverse function f of x of 2 over x minus 3 plus 4. So to find your inverse function, there's a series of steps you must follow. Let's go ahead and go through the steps. To find the inverse, you have to essentially undo the values that are being presented. So here are your list of steps to find the inverse. Steps to find inverse functions. 1, you want to change your function notation to y. So change f of x, change it to a y. Second, you want to interchange or swap your x's and your y's. Third, you want to solve for y. And that's your inverse. So fourth step, we change your y to your inverse notation. So f inverse of x. Those are your 4 steps to find your inverse. Let's go ahead and practice them. In this example, we're being asked to find your inverse. So number 1, we want to change to a y, your f of x to a y. So we will have to go ahead and write y is equal to 2 over x minus 3 plus 4. That's step 1. Step 2, interchange your x's and y's so that we have x is equal to 2 divided by y minus 3 plus 4. So I swapped my x's for y's and my y's for x's. 3, solve for y. I want to go ahead and get y by itself. Okay, so I have x plus 2. X is equal to 2 over y minus 3 plus 4. Okay, let's go ahead and solve. So I need to move the 4. I have plus 4, so I need to do minus 4. Minus 4. I have x minus 4 is equal to 2 over y minus 3. Okay, I need to get y by itself. So I need to get it out of that denominator's place. I can do that by multiplying, or yeah, I will have to multiply both sides by y minus 3. So that I have y minus 3 times x minus 4 equals 2. Okay, well, I just want to get the y by itself. So let's go ahead and divide both sides by x minus 4. That's gone. So we're left with y minus 3 is equal to 2 over x minus 4. Let's move the 3 over, plus 3, plus 3. So we have y is equal to 2x minus 4 plus 3. That's step 3, probably the only time-consuming one. Fourth step is change your y to your inverse notation. So final step, f inverse of x is equal to 2 over x minus 4 plus 3. And that is our answer. So those are your steps. Make sure you have them handy. Make sure you make it a point in your notes. Example, find the inverse function of f of x equals 2 plus square root of x plus 4. All right, same steps. You first want to change f of x to a y. So I have y equals 2 plus square root of x minus 4. Next, I want to swap my x's and y's. So I have x is equal to 2 plus the square root of y minus 4. Next, I want to go ahead and solve for y so that I have to undo all this work. So minus 2, x minus 2 is equal to the square root of y minus 4. All right, I need to undo that square root. So the opposite of square root is a square. Let's square both sides to undo that square root. So then I'm left with x minus 2 squared is equal to y minus 4. Okay, let's get y by itself. Let's add 4 to make 0. Add 4. We're left with x minus 2 squared plus 4 is equal to y. And there we have it. Last piece, write that inverse notation. So f inverse of x is equal to x minus 2 squared plus 4. Finding the inverse function and their graphs. The graph of f inverse of x is the graph of f reflected about the diagonal line y equals x, which we will call the identity line. So here you can see that y equals x is that dotted line, and that allows us to show the image of the inverse. So if you're ever graphing and you need to find the inverse, you can imagine that diagonal line and reflect it over whichever way you need to go. And remember, it's essentially your x's and your y's switched. So if you know a point for your f, you also know the point for your inverse. All right, that's it for the section. Your homework is 7, 9, 11, 17, and 33 to 43 odd. Thank you.